So here we're going to look at covalent bonding. In a previous video, just a couple of pages ago, we looked at ionic bonding. Now both types of bonding work because atoms want a full outer shell of electrons. And to do that, they will go into arrangements with other atoms. So, why do atoms join together to form compounds? Answer: to get a full outer shell of electrons. In one sentence, describe how ionic bonding works. That's the bonding example we did last time, a couple of pages ago. Well, in that one, the metal atom, because ionic bonding is between a metal and a non-metal, so ionic bonding, metal and non-metal, that's what bonds together there. The metal atom gives an electron or electrons. If it's got 2 on its outer shell, it will give 2 away, for example. If it's got 1 on its outer shell, it just gives the 1 away. Okay, the metal atom gives an electron or electrons to a non-metal. And the non-metal accepts. So in other words, it's giving and taking of electrons. If an outer shell has got 1 or 2 electrons in it, or 3, the atom gives it away. Then the shell beneath becomes full. And if a non-metal, and it's always a non-metal, needs, say, 1, 2, or 3 electrons, it will accept those electrons. So that's giving and taking. We've got a different type of bonding here today. It's covalent bonding. Covalent bonding is going to be a different type of bonding. Still trying to get a full outer shell of electrons, but a covalent bond works by sharing electrons. Think about it. If you've got 2 £5 notes on a table, and there's 2 of you in a room, and there's a sign on top of them that says, "Take me, please." If one person pockets both of them and the other gets nothing, you ain't going to be very happy. Well, that's like ionic bonding. The non-metal takes and the metal gives. You'll be much happier, the pair of you in the room with those 2 £5 notes, if you took 1 each. And that's what covalent bonding is, sharing electrons. A covalent bond is a shared pair of electrons, because it's always pairs of electrons, a shared pair of electrons. So covalent bonding is between non-metals only. So the only type of atoms that can involve themselves in covalent bonds are non-metals. Ionic bonding was metal and non-metal. Covalent bonding, non-metals only. Let's have a look at how that works. So we've got fluorine here. Here's a fluorine atom. Fluorine has got an atomic number of 9. So it's got 2 electrons on its first shell and 7 on the second shell. 2 and 7 makes 9. So 1, 2, 3, 4, 5, 6, 7. We've got that one there. So this fluorine is not happy because this outer shell is not full. It wants 1 more. Okay, so the only thing that fluorine can bond with in this case, this is a fluorine molecule, is another fluorine molecule. So there's one F9 there, and there's another F9 there. Now together they're going to make the fluorine molecule F2. So that 2 there means 2 fluorine molecules. Okay, so what there needs to be is there needs to be an overlap. These shells need to overlap each other. And if you think about it, if that one there is going to move that way and that one there is going to move that way, so we end up with that overlap. We end up with a pair of electrons in that overlap. So let's draw all these electrons now down here. This is the F2 molecule, 1 F-fluorine, 2 fluorines. Let's put the 2 electrons on the first shell there, and it has 7 on the outer shell. 1, 2, 3, 4, 5, 6. And let's put the 7th one in the overlap. 7th, there it is. So all we've done is put that one there. These 7 electrons on this fluorine now, 1, 2. Now it's important we do these as dots. These are called dot and cross diagrams. Now of course they're electrons, and these are electrons, and of course they're identical. We do them as dots so we can see where they're coming from and how that's different to the other one. We do these ones as crosses so we can see where those ones are coming from. So 1, 2, 3, 4, 5, 6, 7, 8. We've got the 9th. The 9th is going to go in that overlap there. Try and make it as clear as you can. Okay, so there are my 9 electrons. Now, what's interesting, do they now have a full outer shell of electrons each? So count both outer shells. 1, 2, 3, 4, 5, 6, 7, and that extra one there, 8. This one here now, 1, 2, 3, 4, 5, 6, 7, that extra one, 8. So by sharing this pair of electrons, that's a shared pair of electrons there. That's a covalent bond. A shared pair of electrons. And that is the definition of a covalent bond. So by sharing this pair of electrons, they both get a full outer shell. Okay, so that's our introduction to covalent bonding. Right, so we've got a couple of other examples there we can have a look at. Let's quickly do this one here, the hydrogen molecule. So this is 2 hydrogen atoms, and we've got an atomic number of hydrogen there is 1, so there's our first hydrogen atom. It's got 1 shell. The first shell holds 2 electrons, so we now need to draw another hydrogen atom. Now it has to be an overlap. Covalent bonding works with overlaps only. Okay, so the first thing we're going to do is going to draw the shell, but overlapping that electron. And we're going to put that hydrogen's electron in that overlap. So that's now the hydrogen molecule. Okay, it's made of 2 hydrogen atoms. Both hydrogen atoms have 1 electron, and they're both going in the overlap. This hydrogen's got 1, 2 electrons. This hydrogen's got 1, 2 electrons. Hydrogen and chloride. Chlorine's got an atomic number of 17. Dot for the nucleus, 2 electrons on the first shell, 8 on the second. 2 and 8 makes 10. Third shell, 7 electrons. So it's not happy because it wants 1 extra electron to fill its outer shell. Okay, it's got hydrogen it can bond with, just the 1 hydrogen. Its formula is HCl. So dot for the nucleus, and we're going to draw the hydrogen's shell overlapping, because a covalent bond is always an overlap, and it's a shared pair of electrons. So we're going to draw it overlapping that unpaired electron there, and we're going to put the hydrogen's electron, we're going to do it as a dot, and put it in that overlap. So there's our covalent bond, and that's the hydrogen chloride molecule. Okay, next one. Let's have a quick look at ammonia here. So nitrogen bonds to hydrogen. Nitrogen and hydrogen both non-metals, it's therefore going to be a covalent bond. Nitrogen's got an atomic number of 7. Okay, so that's going to be the one in the middle here. So let's put the nitrogen's electrons on there. 2 on the first shell, 5 in the second. Well, 5 in the second, how many electrons need to fill the outer shell of nitrogen? 5. Okay, 5 means it's 3 short of its full outer shell, so it's going to want to form 3 covalent bonds, hence we've got 3 hydrogens around it. So we're going to put the first 2 electrons of those 5 up there, and then we're going to put 1 in each of these overlaps, 3, 4, 5. So nitrogen's got 7 electrons, 1, 2, 3, 4, 5, 6, 7. Now hydrogen's got 1 electron, so we need to put hydrogen to each of these overlaps. 1, 2, 3. Now it's really important you count the number of electrons in the outer shell now to ensure they add up to 8 for this nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. So by sharing with 3 hydrogens, it gets that 8 electrons. And count each of the hydrogens now. 1, 2, 1, 2, 1, 2. So they're happy as well. It's important you count everything. So this is the ammonia molecule, the NH3 molecule. 1 nitrogen and 3 hydrogens. 1, 2, 3. So what is the rule? What is the rule to knowing how many covalent bonds an atom will form? Okay. However many electrons are needed to fill the outer shell will equal the number of covalent bonds formed. So let's just go back to that nitrogen again up here, just in case, just check you get that. It had 5 electrons in its outer shell before we started. It needed 3 more to get 8. So it forms 1 bond, 2 bonds, 3 bonds. Okay. Next example. Well, you can have a go at those 2 on your own. Actually, no, I'm going to do this one. Yeah, let's do this one. We'll do water together, and you can do that one on your own. Okay, so water, hydrogen, oxygen. Let's draw the oxygen first. It's got an atomic number of 8, so 2 electrons on the first shell, 1, 2, and therefore it's going to be 6 electrons on the second shell. 2 and 6 make 8. Okay, so this wants 2 electrons to fill its outer shell now. So it's going to form 2 covalent bonds. because that would take it up to 8 electrons in the outer shell. What's it bonding with? It's bonding with hydrogen, so we're going to put a dot for the nucleus there, we're going to put hydrogen over that one, and put the hydrogen's electron there, because hydrogen has just the 1 electron. So that's now, let's count the number of electrons in the outer shell now. 1, 2 on this hydrogen, that hydrogen's happy. 1, 2, 3, 4, 5, 6, 7. The oxygen here isn't happy, so it needs to bond with another hydrogen. So we're going to draw another hydrogen overlapping that electron, that unpaired electron, and we're going to pair it up now with the hydrogen's electron. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. Now the oxygen's happy, and both hydrogens. 1, 2, 1, 2. That's the H2O molecule. 2 hydrogens, 1, 2 hydrogens, 1 oxygen. You can do that one on your own. And let's do this example here now. These are now higher examples, and I've just got time to do these. Okay, so it's the oxygen molecule. The oxygen molecule is the O2 molecule, of course. So it's 2 oxygens. Okay, so 2 electrons on the first shell. 1, 2. Okay, 3, 4, 5, 6, 7, 8. So 2 and 6 make 8. Okay, now if we look at this, this oxygen wants 2 extra electrons. Okay, so it's going to form 2 covalent bonds. Now, a covalent bond is a shared pair of electrons. So this oxygen, therefore, wants to share not 1 pair of electrons, but 2 pairs of electrons. And the only thing it can share it with is another oxygen atom. So with this extra oxygen here, this next oxygen, we're going to draw it over not 1 electron in that outer shell, but 2 electrons in this outer shell. Because oxygen has got 6 on its outer shell, it wants to get 2 electrons, so it's going to form 2 bonds. So let's put these oxygen electrons on now. 2 on the first shell, 3, 4, 5, 6. Now remember, it wants to form 2, so it's going to put 2 into the overlap. 7, 8. Okay, so let's count up and check they're all right. Outer shells, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is what's known as a double bond, a double covalent bond. And that's a higher example. It's harder than these examples up here. These are single bonds. So if you wanted to draw this with just lines, it would look like that. There's a water molecule, and here's an oxygen molecule now with a double bond. Okay, carbon dioxide now. Draw the molecule formed when carbon and oxygen react together. Well, that's a CO2 molecule, CO2. So it's 1 carbon and 2 oxygens. Let's draw the carbon first. Okay, carbon in the middle there. It's got 6 electrons. Excuse me, 2 electrons on the first shell and 4 electrons on the second shell. So 4 electrons on the second shell. How many electrons does it need to fill its outer shell? Answer, it needs 4 more. 4 and 4 makes 8. So this is going to form 4 bonds. Now there's 2 oxygen atoms. So it's going to be 2 bonds with 1 oxygen and 2 bonds with another oxygen. So let's put another oxygen over those 2 electrons there. That's the outer shell of the oxygen. Let's put the inner shell in now. So that's 2 on the so oxygen had an atomic number of 8. I put 2 electrons there, so it's 6 on the outer shell. So it needs 2 more, so 2 are going to go in that overlap. 3, 4, 5, 6. So that oxygen, let's check it's happy. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that oxygen's happy. Let's check the carbon. 1, 2, 3, 4, 5, 6. Carbon's still not happy. It wants 2 more electrons. It's going to get those from another oxygen. So we need another oxygen over here. Right, so that's the outer shell. Let's do the inner shell now. 2 on the first shell. Oxygen has got 8, remember. 2 on the first shell. 3, 4, 5, 6, 7, 8. Right, let's count the carbon in the middle now. 1, 2, 3, 4, 5, 6, 7, 8 electrons on the outer shell. That's happy. 1, 2, 3, 4, 5, 6, 7, 8. That's happy. 1, 2, 3, 4, 5, 6, 7, 8. That's happy. Always count at the end. What is it called when you share 2 pairs of electrons between 2 atoms? A double bond. Okay, and there's an introduction to covalent bonds. There's some more questions on the next page. You can do those on your own.